All right, guys, let's take a look at this problem. It says find the absolute max and min for the following function on the closed interval 0, 4. All right, well, I know that this is a polynomial. It's a continuous function on the closed interval 0, 4. So that means by the EVT, by the extreme value theorem, there has to exist an absolute max and min for this function. My question is, well, how do I find it? Well, if you remember my three-step process, first thing is find your critical numbers. So to find the critical numbers, I got to find the derivative of the function. The derivative of the function would be 3x squared minus 12. And then in order for it to be a critical number, it has to be where the derivative is equal to 0. So I'm going to solve this. 3x squared minus 12 is equal to 0. If I notice, I can pull out a GCF of a 3. That'll leave x squared minus 4. And then I also notice that the x squared minus 4 is a difference of two squares, so I can factor that into x plus 2, x minus 2. And so I've got it fully factored, so I'm going to take everything and set each thing equal to 0. And then for the first one, 3 is equal to 0. It makes no sense, so I can just simply cross that solution out. But I end up with x is equal to negative 2 and x is equal to 2. So those are my critical numbers. Well, I need to find the value of those critical numbers. So I want to find the value of f of negative 2 and f of 2. Okay? All right, so let's find out what f of negative 2 is. Now, very crucial, guys, you don't plug it into the derivative, you plug it into the original function. So my original function is x cubed minus 12x. So if I plug in negative 2 into that, negative 2 cubed minus 12 times negative 2. Negative 2 cubed would be negative 8. Negative 12 times negative 2 would be positive 24. And then negative 8 plus 24 would be 16. So that's the value there. Also, I need to plug in 2 and figure out what that value is. So now I'm going to have 2 cubed minus 12 times 2. 2 cubed is 8. Negative 12 times 2 is negative 24. 8 minus 24 is negative 16. All right, but you're not finished. Not only do you have to find the values of the critical numbers, but you also have to find the values of the endpoints on the closed interval. So I need to find out the value of f of 0 and f of 4. Remember, plug it into your original function, not the derivative. So 0 cubed minus 12 times 0, well, that's easy. That's just going to be 0. And then f of 4, so I'm going to have 4 cubed minus 12 times 4. 4 cubed is 64. 12 times 4 is 48. 64 minus 48 is 16. All right, now with all four of these values, the way that you find your absolute max is it's the highest value. And the way that you find your absolute min is it is your lowest value. So let's look right quick. 0, 16, 16, negative 16. There's my absolute min. It would be at the point 2, negative 16. And then my absolute max, I've got two of them, right? Because 16 appears twice. So my absolute max appears at 416. So that's the first point. And the second point would be negative 2, 16. And so that would be my absolute max and then my absolute min.